Good day, everyone. Thank you so much for taking time out of your day to attend our session on aviation safety and bushfire conditions. My name is Shaun Holmes. I'm one of the aviation safety advisors from CASA Sydney office. And you'll see also with us today is our guest speaker, Rick Roberts. Rick is a captain for Conair Aviation flying the RJ85. Thanks, Rick, and welcome.
Thanks for the invite, and hopefully we have a good discussion today. Thanks.
Thank you. Now, before we get underway with today's presentation, I would like to respectfully acknowledge the traditional custodians and knowledge holders of the lands we meet on today and their connection to land, water and community. I pay respect to elders past, present and emerging. I'd also like to extend that respect to the Aboriginal and Torres Strait Islander people who are in attendance today. Now, a little bit of housekeeping before we get started with the presentation and work our way through some of my presentation and then onto the insight that Rick is going to provide us today. As I mentioned, a little bit of housekeeping. The webinar is being recorded. It will be available shortly on the CASA Pilot Safety Hub and also on our YouTube channel. You'll notice that your microphone and camera has been switched off to help preserve some bandwidth. You will be able to ask and submit some questions to us throughout the presentation, and we do plan on having a little bit of time there at the end for us to answer those questions. So in your chat function, you'll be able to pop up to the top bar in Teams, open the chat bubble. You can type and submit your question into there, and we'll do our best to answer those questions as they come through at the end of the presentation. We also, as part of our Avsafety webinar series, are offering a digital badge by partnering with Credly to recognise your continuous commitment to learning. So you can add it to your resume, your email or your social media, whatever capacity you would like to use. How do you get the badge? Just need to stay for the full webinar, and you can do that in any capacity. We can't see you, so as I mentioned, it's fantastic to have you here, and we really appreciate you taking a bit of time out of your day to listen to Rick and I. So what are we going to cover today? We'll look at some bushfire weather conditions and some common conditions that we can expect to see around bushfires and also generally associated with bushfires. We'll look at having airspace awareness and some of the areas that may be restricted around bushfires and the types of space that a bushfire aerial firefighting operation may need and how far we may need to avoid that area by. We'll cover some operational considerations and tips, but what I would like to do is really, at the end of my presentation, give that opportunity to Rick to give us some insight and some valuable information on how a professional pilot and an operation deals with those bushfire hazards and get some practical tips there as well. So what kind of weather conditions and potentially hazard conditions can we expect to be associated with a bushfire? Well, we can expect that we are going to have some turbulence. Now, I mean turbulence that's created specifically by the bushfire, as well as when we talk about conditions that are normally associated with bushfire conditions, such as strong winds, which means that we may have some mechanical turbulence and mountain wave, that sort of thing. So we can expect some moderate to severe turbulence to come from a large or severe area of bushfire. It also means because of that heat, rising air, that creates a lot of atmospheric instability, which can lead to convective clouds. And we're talking about convective clouds like pyrocumulus and pyro-CB. So yes, a bushfire, similar to what you can see pictured there, can generate a thunderstorm. And that's where we can also have some associated turbulence and some associated wind conditions as well. So again, we can see these all fit together. there may be generally forecast strong wind conditions to go with the bushfire. We may also have some microburst, downburst, and very changeable gusty wind condition as a result of convective clouds as well. So the wind can be quite significant and changeable at the same time. Probably the most obvious one that we all consider immediately when we talk about bushfires at this time of the year is the smoke and the reduced visibility from that smoke. Now, I will talk a little bit more about maybe how the smoke sits and the different ways that we need to consider identifying smoke and reduce visibility in a few more slides. The last item I wanted to raise was the high ambient temperatures. Again, we normally associate when we have those strong sort of bushfire conditions with high ambient temperatures as well. So, I mean, that can have effect on the actual fires themselves and the strength of the fires. That can affect the performance of the aircraft across a number of flight phases. It can also have an effect on us as human beings and our human performance. So high temperatures do mean that we are likely to become fatigued more quickly. We have to deal with dehydration. We could have eye irritation, breathing difficulties, even in lower levels. So those temperatures can affect us as well. They can also affect the equipment that we're using, okay? I know that a lot of pilots out there are using electronic flight bags, and they are a fantastic piece of equipment, but they are also affected by the heat and those high ambient temperatures as well. So look, there is quite a bit there to consider, even when we think more generally, okay, yeah, bushfire, we want to avoid that for obvious reasons. It's nice just to take a moment to have a look through some of those main hazards. So what is the best way to understand where the bushfires are, where those hazards might be located? Well, we need to access our weather forecasts and our weather reporting to understand what kind of conditions might affect the flight that we have planned. So using NAIPS, we're talking about things like your graphical area forecast, your terminal area forecast, GAF and TAF, METAR and SPECI for reporting. The grid point wind and temperature charts can be quite helpful from a temperature perspective, but also having an idea of the general wind direction can also give you an idea if the fires are more isolated, where the smoke may be travelling. If you're operating above 10,000 feet, a significant weather chart can give you some information, maybe not specifically about smoke, but certainly some thunderstorm and other hazardous weather information. And there may also be some AMETs available, which will certainly give you some specific information about areas of smoke, the coverage of that smoke, the effect on its visibility. So all of those normal areas that we would be looking are extremely helpful. Now, from a reporting perspective with the METAR and the SPECI, there are some limitations. So where we talk about an automatic SPECI, it's difficult for automated equipment to detect the smoke with the automatic visibility sensor. So it may code the smoke as haze or dust, and it may be difficult for it to give an accurate reading of visibility, and also cloud-based as well. So the Bureau of Meteorology also, when the conditions in the sky are obscured by smoke, provide vertical visibility, which is something some of you may have heard of before. It's provided in your terminal area forecast in your TAF and your critical location forecast in the GAF. And it's provided in lieu of that cloud information when smoke is obscuring the sky. So it can help you get a better understanding of how the smoke is sitting and what the effect on the visibility is. So you can see with the diagram there, when we have a cloud ceiling or a low cloud ceiling, we generally have quite good visibility and a clear delineation between the cloud and sort of the IMC conditions and the VMC underneath. We can see with very widespread smoke conditions, the visibility can be quite low across a large amount of area, and we can also have more problems with the slant range visibility as well. So that probably becomes more important in the last example there, where we might have a smoke layer trapped underneath a temperature inversion, where the conditions are good, VMC conditions above the inversion, and may look good when we look down through it. But once we actually get into entering that layer of smoke and we experience that slant range visibility, there can be some quite different effects as well. So we recommend, in terms of using vertical visibility, you should treat the vertical visibility height. Yes, vertical visibility is given in a forecast in hundreds of feet using 3 figures, so it's read like a cloud height. We recommend that you treat that visibility height as equivalent to more than scattered cloud when you're determining conditions for departing on a VFR flight, or whether you need to select an alternate aerodrome. So we can see in the example provided there of a pre-TAF3 Melbourne TAF, we can see some visibility, smoke, and a vertical visibility of 1,000 feet. And we can also see there in the GAF the smoke information as well. So that is just a little bit of extra information to help understand what the smoke conditions are doing and get a better idea perhaps of what it may look like. Yes, of course, weather cameras can be beneficial and good for situational awareness as well. So once we've identified those areas where we expect there are active bushfires and those associated weather conditions, it's very likely that there are going to be firebombing and aerial firefighting aircraft operating on those bushfires. So how far away should we stay? Well, the AIP recommends that due to potential aerial firefighting traffic, crewed aircraft remain a minimum of 5 nautical miles and 3,000 feet AGL from any bushfire. And I would stress, and we're going to hear more about this from Rick very shortly, I would stress that that would be a minimum, because we're talking about a large variance of aircraft operating on that fire, from your smaller aircraft, single engine air tankers, and your rotary aircraft, all the way up to your LATs, your large air tankers. So they can be using or needing a bit more room for that area as well. So alongside the weather information giving us an idea of where the bushfires are, we can expect that, as I mentioned, there'll be aerial firefighting aircraft operating on near those bushfires. A NOTAM can be issued by a relevant state authority to notify of a specific location where those operations are taking place. They don't necessarily have to, and they can notify of specific operations taking place, which you can see an example there of a recent fire that occurred in New South Wales. And you'll see it's specific to an 8-mile radius from the location, and there's some contact details there as well, and up to 4,000 feet AGL. Now, using the weather information, yes, we can identify those areas of bushfire. There may be a NOTAM there that's available. You can also consult your local rural fire service website for specific information about the actual locations of bushfires, and that can give you some additional information as well. So, Bernie, we have a link for that to drop into the chat for everyone for those local fire service website locations. And if you would like some more information on vertical visibility, smoke, some of those hazardous phenomena, and the forecasts and reports that we've spoken about, the best place to look is the BOM Knowledge Centre, which I believe we also have a link for everyone in the chat as well. Now, if the risk to airspace users becomes elevated above that general warning in the AIP, or a general NOTAM provided about aerial firefighting operations, then that relevant fire agency may request a temporary restricted or temporary danger area to be published or declared. And access to those areas is going to be dependent on the type of airspace and also who the controlling authority is, okay? So to look and find for that specific information, we're now talking about NOTAMs. So using access to your location-specific NOTAMs, your special use airspace, your flight information region, your FIR, and also your head office NOTAM. So it is important to make sure that we're looking at all of those NOTAMs so we can see if there are any NOTAMs advising of aerial firefighting operations or if there is any temporary airspace in place for aerial firefighting as well. And that can help and give us a good idea of those larger concentrations of aircraft and just help get us thinking about not only those hazardous weather conditions, but also that concentration of aircraft, as I mentioned, is also a hazard that we are going to have to manage for that particular flight to make sure they've got the space to do the job that they're doing. So within that area, on the fire ground, where those aircraft are working, they could be on a discrete or an unpublished frequency. Firefighting aircraft are fitted with ADS-B out equipment, so if you do have the ability to have ADS-B in your aircraft, then you will get the added situational awareness benefit of being able to see where some of those aircraft are operating. Now, of course, if those firefighting operations and aircraft are operating in the vicinity of a non-towered aerodrome, or they are travelling to and from a non-towered aerodrome for refueling, reloading, that sort of thing, of course, you're going to hear those aircraft broadcast on the CTAF, and they will very likely be monitoring the CTAF. And I believe Rick's going to give us a bit more information and maybe an example of that shortly as well. Okay, so we'll move into just some practical tips and a little bit of information so we can analyse all of that information and put it together to help plan and conduct a flight if there are bushfire conditions that are existing on the day. So using the time during the pre-flight stages to analyse that information from a variety of sources is extremely important. We talk about it all the time, and it's because having the highest quality information available means that that leads to better decision making. So as we've discussed, use that time to look through your weather reporting, your NOTAMs, bushfire locations on the websites, and that can help you come up with a plan. Where can I fly? How can I conduct this flight safely? Consider the threats you're going to encounter and the mitigators that you may have available. And as an example, and a good way of doing it is using the PAVE checklist as a risk management tool. So what does a PAVE checklist look like? Well, it covers 4 main areas: the pilot, the aircraft, the environment, and the external pressures, which are all good areas that we need to consider. So from a pilot perspective, we should do this before every flight. Ask, am I ready for this flight? Am I recent, current, proficient? Is it within my personal limitations? Is this something that I'm comfortable with and that I've done before? Or I can get some information about how to deal with those conditions safely. And of course, conducting your own safe, especially if you're going to have very high ambient temperatures, it's going to be a hot, sweaty kind of flight. That's going to affect you as well. Okay, when we consider the aircraft, is the aircraft capable of the proposed flight? Which is more of a broad question around, is it capable in terms of the aircraft performance for the aerodromes that I intend to operate at, for the altitudes I intend to use? Does it have sufficient fuel carrying capacity and load carrying capacity for what I would like to do for the conditions? Okay, the environment being the big one. Identifying those areas of active bushfires and where those hazardous weather conditions exist, so we can come up with a plan on how we're going to avoid them. And if we cannot avoid them, then we need to think about, well, can we actually manage that hazard? Is it within, for a VFR flight, the minimum of VMC and what the aircraft and what you are capable of, or is it not possible for us to manage? So that's something that you'll need to put together and think about and consider during those pre-flight planning stages, because it's going to be slightly different depending on where you're flying, kind of aircraft you're operating. Okay, and look, it's sometimes we have to accept it. It may not be VMC or close enough to VMC, because 5 kilometres visibility is quite a low number. It may not be possible when there is bushfire activity active, or there may be so many bushfires in a close proximity. It's very difficult to give those aerial firefighting aircraft some space to operate as well. So we do need to keep that in mind. And as I mentioned, it's important to identify those airspace restrictions and coming up with a plan of where we are and are not going to be able to fly around those aerial firefighting operations. It's a fantastic idea, and I would recommend having additional and sufficient fuel and expect to have some delays and possibly some diversions, because the conditions can change so quickly when we're talking about bushfires, which again, Rick's going to give us some great information on. Have an alternate aerodrome where an alternate aerodrome is required based on cloud base and visibility. From a weather perspective, I would definitely strongly recommend that in any case, you carry an alternate aerodrome that is not affected by a bushfire, but of course that's up to you. Or if it's not possible, ensure that you have more than one option available. Okay, so what I'm saying is it's a great idea to have plan B, plan C, plan D, because the conditions can change quite quickly. The wind direction can change, the fires can get stronger, and that may affect your in-flight conditions quite quickly. The last part of the PAVE checklist is the external pressures. And these are the pressures that we feel internally and that we also feel externally as well. Okay, there's a pressure to complete the flight, often under adverse conditions. So a great way to manage that, and an example of managing those external pressures, is using personal SOPs. So that could be an acceptance of delays that we expect on a day where there are bushfires and smoke. We may not be able to have a nice crystal clear flight, that we are going to have to work through a few items. Managing expectations of those around you, your passengers, and just remembering that your job as the pilot command is to manage those hazards rather than creating additional hazards. So yes, those pressures can affect all of us, where we talk about a commercial operator all the way down to a private and recreational flyer that needs to get somewhere for an event or for the weekend. So it's important to take note of that, think about what those pressures are and manage those as well, so we're not going into and putting ourselves in those adverse weather conditions. And we can see that imagery there. That's from the bushfires of 2019, 2020 from Sydney Airport. So we can see very, very low visibility. And we've used that time during the pre-flight to consider all of our options. We've come up with a plan, a route that we think will work. Once we are in flight, we should continue to aviate, navigate, communicate, and manage the aircraft. We need to monitor weather conditions, including the destination and alternate weather, again, because the conditions can be very changeable very quickly. Make deviation and diversion decisions nice and early. Alerted scene avoid will be more difficult because of the reduced visibility conditions. So maintaining a good lookout, monitoring and broadcasting on the appropriate CTAF frequency, announcing, using clear and concise radio transmissions of your intentions early can help. At a non-controlled aerodrome, using more standardized arrival and departure procedures can also be of assistance. You are more predictable. If you have aircraft equipment that helps you identify other traffic, that can certainly help improve your situational awareness as well. So we can see overall that there can be some quite significant effects of just having a bit of smoke and reduced visibility in the air. So that concludes my time presenting to you today. Thank you very much for bearing with me through that. I would now like to hand over to our guest presenter, Rick, who is going to speak with us today and give us some insight on aerial firefighting and also a perspective of how he manages the kinds of risks and hazards that we've discussed so far. So thanks very much, Rick. Take it away when you're ready.
Thanks, Shaun, for that, and thanks everybody for attending today. I hope the information I put together it'll be generic, but it'll be helpful, I'm hoping, to people that don't understand our business. In order for us to be effective at what we do, aerial firefighting, and manage the risks, we need to have an understanding of fire behavior and the weather patterns it creates and the weather patterns that are ambient around the fire. We also need to understand how we integrate firefighting aircraft around a fire, which includes the fixed-wing aircraft, the large air tankers, the single-engine air tankers, we call them seats. We have fire scanners, bird dogs, helicopters, and we'll talk a little bit about how we integrate all those. How we communicate with each other, we need to know that, and all this knowledge and understanding will help us manage the risks and stay safe during our firefighting operations. So I'm going to start off and just talk about a little bit about the conditions that influence a fire. And there's three key factors in the turquoise circles that influence bushfire behavior. In a summary, it's a type of fuel that we have, whether it's grass, bush, trees. It also depends on the moisture content. Obviously, the drier the moisture content, the more volatile fires will be. What's the weather pattern around a fire, whether it's stable or unstable air mass, what's the temperature, and again, the humidity. And also the topography has a huge factor, whether the fire is on flat grounds or it's in a slope. And so understanding these particular elements is crucial for us to predict, manage, and fight these type of fires. So the type of fuels are important for us to know. There's fine fuels, which are dry grass, leaves, small twigs, etc. They'll burn quicker and have a higher rate of spread than the heavier fuels, which will be the bush, large trees. They'll burn slower, but the disadvantage that we face is that they burn slower, but they also burn harder. So that plays a part of fire behavior. Moisture content, obviously the drier the fuel, the easier it is to ignite. That is something that we always take into consideration when we plan the strategy. And also the fuel arrangement, which is it trees going into up against rivers, roads, grass, acreage. So we want to understand before we head out what we're facing with respect to how the fuels are arranged with respect to how we fight and what assets are required to deal with that. Weather, temperature, and low humidity is important for us to, again, we talked about that, the atmospheric stability, we've hit on that, and Shaun hit on it a little bit in his presentation. The topography, one of the things that is important to us, slope has a major impact. If the fire's in a hill or mountains, the fire will spread faster uphill because the flames are closer and preheat the fuel ahead of them. An idea A rule of thumb is for every 10 degrees of slope, their fire speed, the rate of spread is about double than what it would normally be on a flat surface. Where the slope is facing, if it's facing into the sun, it will obviously receive more heat from the sun and increase the dryness of the fuels, and they become more susceptible to burning. Three ways basically fire is spread. There's direct flame contact. So that's just one back from that, Shaun. Here we go. The direct flame contact, that would be a in both situations, that's where the flames physically touch unburnt fuel. Radiant heat, and that would be something in the left picture. The ambient winds are taking the fire to unburnt fuels, whereas in the left picture, there's no much ambient wind. So the fire is spreading not so quickly, but burning because of radiant heat, which means that the fire is preheating the nearby fuels to their ignition temperatures, and then the radiant heat is becoming the source of spread for that particular fire. One of the most challenging parts of any fire is spotting burning embers. When the ambient winds are high, as in the picture on the left, we will get embers off the trees, and they will spot a quarter mile, half a kilometer, quarter kilometer ahead of the fire, and start new fires ahead of the fire. So this is one of the downfalls, and the biggest enemy of fires down here in Australia is the wind, and that's one of the biggest factors that we have to face. What is a fire? What causes fires? There's the fire triangle. Some of you have probably heard it. There's three things that you need to have a fire, which is heat, oxygen, and fuel. If you take any one of those three components away from a fire, the fire will extinguish. So our job in aerial firefighting is we take away the heat and the fuel. So when we use water from the seats and do a direct attack on force on the fires, and they drop directly on the flames, we're trying to remove the heat. Whereas the aerial fire, when we carry retardant, the large air tankers, we're typically laying a line of retardant in unburnt trees. We're actually putting them down. And what we're trying to do is cover the fuel source so that the fire can't penetrate it. And of course, if we take the fuel away, then the fire is more controllable and will extinguish. At least the idea is that the fire would come up to our fire line and then stop, which is the intent. So that's the main components of fire behavior. The weather around a fire is something we also need to know, and this is interesting because local weather conditions can create wind patterns that affect the fire, but the fire itself can alter those wind patterns. They can also increase the turbulence and reduce visibility. So because the fire interacts with ambient wind conditions, they can generate their own fire system. So the example that you're looking at, you have a large fire which creates an incredible amount of heat. Air rises and creates a low pressure area. So what happens after that, the reaction is the ambient air around the fire gets sucked into the fire, and that lateral movement of air into the fire is a new source of wind, creates turbulence, and it will eventually be heat, and it will rise. We have to be well aware of that because that's exactly where we're flying most of the time. And so we anticipate gusty wind conditions and obviously rapid change in fire behavior can be unpredictable because of the wind changes that occur at ground level. The rising air obviously can you'll see it in dark black smoke. As the rising air cools, it'll take a more whiter form cloud. If the air mass around the fire is unstable, this whole process could create its own, as Shaun already mentioned, pyrocumulonimbus clouds, and it creates its own storms where you can get downbursts and lightning as a result. Those are extreme conditions, but they do happen. And again, it's something else that we need to be aware of when we get dispatched to a fire and we know the fuels and the wind conditions. The next slide is a pretty good example of a fire behavior. And here's a situation where you can see the ambient winds is moving the fire along, and you can see in the background there maybe some slightly unstable air mass where you're starting to form some cumulus clouds. Visibility underneath the fire along, we call that the head underneath. If you were to fly under that, the visibility very poor, and of course extremely turbulent. The next slide, just a couple of more examples of how ambient wind affects fire behavior. And when we get a wind shift, and as I mentioned, in Australia, we do get typically higher winds than we do in most other continents that I've flown in. So it's always something that plays a big factor. And when the wind shifts, what could happen is a fire that we would call along a flank, which is not very active. If the wind switches, the flank could also become active if it's being influenced by the local wind shift and by the local ambient winds. So that changes the entire strategy on a fire. So higher wind speeds, sudden wind changes also become a big part for us. The next slide shows another example of where you have ambient winds, slight on the left, and a fire on the right with very little ambient winds. You can see it's just churning along, not getting, it's just burning into itself. And it's an example of how the winds create fires. We'll get into the next slide, which is how turbulence gets created. When the fire creates significant heat, we're looking at the left picture, it creates strong rising columns of hot air, and the hot air is called collective plume. That's the cloud that creates. That rising air obviously would be moderate to a severe turbulence. Basically, it can be up to 4 or 5 times that you would experience outside the column. When the hot air goes up, it needs to be replaced by the cool air ambient around the fire, and that is something that would be local to the ground level of the fire itself. Sometimes we get, and that creates a continual pattern. Sometimes the pattern can create what on the right-hand side, you'll see a fire whirl or a fire tornado. We see these quite frequently. And that's an interaction of the rising air you see on the left with the different wind speeds and the wind direction, typically wind shear, can cause the air to start spinning. And of course, these are quite dangerous and are highly destructive to both ground and obviously to aircraft. So these are some of the hazards that we have. Next slide that create some of the low visibility issues that we face. And the visibility is significantly reduced, often to zero, because of the large smoke and ash and matter that's the fire releases into the atmosphere. If there is very little wind, the smoke has a tendency to lie down, and if it's smokes in a valley, it can be trapped in a valley. And of course, if there's a weather inversion, the smoke can lie underneath the inversion. Huge hazard for us, working fires. It's a hazard for general aviation because the low visibility can be contained well outside our traffic zone, which is I'm going to talk about next, and of course become an aviation hazard. So those are some of the basic hazards that we have to understand and manage every time we go to a fire action. So what we'll do now is let's talk about the airspace around the wildfire, bushfire, how it's defined, how we as aerial firefighters make it work, and what are some of the common misconceptions about the fire zone. So aerial firefighting, it combines two relatively high-risk environments. It takes a wildfire situation and combines it with aviation. So what happens is often we get multiple firefighting aircraft operating in close proximity with each other, and in limited visibility and unfavorable weather conditions, for example, turbulence, this can be quite complex. And in order for us to keep it safe, there's a highly organized procedures that each aircraft over a fire is trained to follow. And those procedures involve both lateral and vertical separation of all the aircraft. And so every aircraft that's over a fire, and I'll get into that a little bit more detail, know that we're there. And one of the hazards that we face as air tanker pilots and firefighting aircraft is the threat of an unauthorized general aviation aircraft entering the zone. And you've heard, I'm sure, of drones being people with their drones entering this airspace, this complex airspace. And of course, those are hazards to us, and it could cause a fire zone to completely shut down until they're dealt with. The Shaun mentioned earlier the lateral and vertical coordinates around a fire is 5 nautical miles and 3,000 feet. I would suggest that that's a minimum. We'll get into that in a bit more detail. That's a minimum standard, and I'll talk about why that is in a minute. So how do we make this work? So the picture you're looking at, you're probably wondering what it is. We call that, it's called a stack. And the stack is in we call it a fire traffic area. It's an area that we've established. It's what you would know as 5 miles and 3,000 feet, but that's just a general rule because a fire, as you've seen in the previous pictures, could be quite larger than that. So your fire traffic area will be corresponding to the size of the fire that it surrounds. Well, what we do is that we organize the airspace above and around, as I mentioned, and there's a standard set of procedures that's used by all the states. And it's basically the playbook that tells us what to expect as air tanker pilots prior to our arrival. Each aircraft coming into this stack will be sequenced. They'll have an assigned altitude, a sequence number of how they work on a fire, and of course their assignment on a fire. And it's not just for the air tankers, the large air tankers that we fly. There's also multiple other aircraft that are incorporated into this large column over the fire. There's helicopters, obviously the single engine, large engine air tankers. There's large air tanker ass platforms. They're the fire scans or the bird dog aircraft that coordinate the air traffic control over these fires. If the fire gets complex, we'll have another an incident air attack supervisor in another aircraft or in a helicopter, and he will also act as a air traffic control. They'll coordinate between the two. We may have mapping or scanning aircraft, and sometimes even media aircraft all on top of each other from the ground level right to up to 3 or even higher, 4,000 or 5,000 feet. The control of all this traffic is done, as I mentioned, by the large air tanker air attack supervisor, which sits in the fire scanner bird dog aircraft that accompanies all the air tankers to the fire. And they use multiple VHF and FM frequencies to communicate with all the aircraft and ground personnel over the fire. Contrary to what people believe, we also have to get authorization. Every aircraft that enter into this fire zone has to be given permission. We check in ourselves, the large air tankers, 10 miles and 5 miles back from the fire to get authorization. And you'll see the different color codes. We as large air tankers will get into a stack above the fire between 1,500 and 3,000 feet above the fire or the target elevation. Below us, below the 1,500 feet, are these single engine air tankers and multiple helicopters doing specific jobs on the fire. So we're stacked above them. And then stacked above us are things like the media aircraft and the scanning aircraft. There's an open line of communication with the aircraft, the LAT or the fire scan, the bird dog that is controlling, doing air traffic control over a fire, and he has access to all these aircraft, and he coordinates each of their tasks. And when we are assigned our drop runs, his job is to coordinate the helicopters and the seats. They will move out of the bottom 1,500 foot airspace there, and the air tankers will leave that light brown area one at a time and come in and do their drops. So that's a basic overview of the traffic. So for the general aviation people that come up to a fire and they don't see aircraft, well, they might not be looking high enough, or the visibility might be reduced enough they don't see them. But be assured that any fire that is of any kind of activity, be assured that there's probably a stack that's over the fire with multiple aircraft. Simple slide on how we maintain separation. Obviously, the common we've maintained separation visually, see and avoid. We do provide position reports. Sometimes we have to hold out of a fire zone, but generally, every aircraft that arrives into this stack knows of the other aircraft that is there. So see and avoid is our primary method. We are also stacked vertically up at a minimum of 500 foot separation. So we all run off the same altimeter settings that's been given to us by the platform that's running the air attack, or that's running the air traffic control. So everybody's running off the same altimeter settings, and we are separated by vertically by 500 feet, and of course laterally by visual contact. When for the lower levels, for the helicopters and seats, they also separate themselves horizontally by establishing set patterns. I'll talk about this in a second. The seats, if they're fire bosses and they're picking up of water, they will follow each other out to the lake or to the water source and come back in as a specific route. They may have landmarks that help them. And again, they maintain separation visually, but they follow themselves laterally, one behind the other. There's sometimes it gets complex where there's specific routes that are required, and we as air tankers and the traffic above the fire that will eventually go down into the airspace will have knowledge of where those routes are, and those aircraft will clear temporarily out of the way for us. When it gets the traffic gets too congested, there could be holding points for us, specific routes, as I mentioned, and a specific way to get into a fire and out of a fire. Again, all that is the job of the aircraft that is running air traffic control, being the LAT. We call them MAS, last air attack supervisors, or the incident LAT that, or incident air attack that is managing the fire. But the main point is that always somebody is managing the traffic over the fire. So what is that traffic? Communication obviously is the most important thing for us. The air attack supervisor, again, acts as air traffic control. He coordinates all the traffic on predetermined radio frequencies. He manages the flow, the altitude, and each of the specific assignments. All the aircraft that are over fire, we have mandatory calls. Again, it's 10 miles and 5 miles typically. And we all work on a common altimeter settings. We use discrete VHF and HF frequencies to communicate. We do have, each fire is assigned a CTAF, and we are all, which is available to all the aircraft over a fire. When the fire is, for general aviation people, when the fire is near an airport, we had a fire out towards Mudgee, which is just outside the CTAF area. We will attempt to monitor those frequencies for aircraft that are not participants in the firefighting roles, but are transiting in and out of the Mudgee Airport. If we don't respond, or if you're asking, we don't respond, just stand by. They're probably busy, but we do our best to monitor all CTAFs. But we do have CTAF specific ones for the fires, and we monitor the CTAF when we are conflicting with especially uncontrolled airports. What we also use to supplement our communications is every aircraft has a TCAS, and we all have ADS-B. A lot of what we communicate is the information to keep us separated. There's specific information that goes back and forth about elevation of the fire and intended drop area. We have the strategies, the fire strategies, once they're decided. So this gets relayed to us. Any communication plans, if there's updates, other aircraft coming in, we get advised of that. We get advised of all the known hazards that are associated. If there's a change in the objective, the bird dog, the fire scan, whoever the large air attack air attack supervisors, they do an assessment of the terrain. They identify what's safe to approach and the departure paths, and they identify any of the weather that we just talked about, weather, turbulence, visibility, and any unknown wind shear factors that may affect our runs. So all the stuff that we just talked about now comes to the fire zone, and the bird dog, which is the top aircraft there, the Citation. He basically quarterbacks everything that's over the fire zone. So the point is that there is a ton of communication over any fire zone, and the guy that's sitting up top there, he quarterbacks the communication for everyone else in the stack. We all have assigned frequencies. And although we are not in direct communication with the helicopters and the seats which are flying below us, we do have the ability, if required, to talk to them through what we have, which through our CTAF frequencies. The point being is that there's a lot of radio chatter, and it's organized, it's complex. But the idea is that when we do get to the fire, it's fairly well orchestrated, and minimal talk is required out of the bottom 5 aircraft. The guy up top, he works the hardest, and he's constantly on the radios. That's a summary of how we communicate. There's some common misconceptions that we have about temporary flight restrictions around a fire. If there's no TFR that's posted, the 5 nautical mile and 3,000 is a minimum standard. The 2 slides that you're looking at is just some tracking around a particular fire, and you can see that aircraft, there's multiple aircraft there, and some of the tracking is well outside the 5 nautical mile range. And the reason for that is that we have small seats and we have large air tankers, and we have, as shown on the bottom slide, the tracking from a fire to the water sources. If air tankers are going to and from airports to get reloads, that we're leaving these fire traffic areas that have been established. So for the general aviation pilots who think they can come up and get within 5 miles of a fire because that's what they are led to believe, the common misconception is that you should stay a little bit further away from that, because there will be traffic that'll be sometimes outside that area. One of the other misconceptions for the general aviation pilots is that there is always a TFR over every fire. That's not the case. Often it takes time to set up a restricted airspace NOTAM, so that could happen several hours after the fire has started, and so there may not be one. But when it does come out, don't expect it to be just at the fire. It could be quite a large area that gives us the opportunity to work within the established TFR without the risk of getting general aviation traffic mixed up with our complex operations. The other misconception about fires is when a general aviation pilot sees a fire, they feel the need, they have to go and look at it. They don't. Typically, that any fire that is in New South Wales or anywhere that you're flying, very likely has already been reported. Very likely has already been. They have aircraft over it. But if you are uncertain, there's ways to do it through ATC 000, and there's some links that'll be available for a follow-up on that. Finally, firefighting, what we do, that was a quick overview, but the large part of our job is all about risk management. And before we actually get in the airplane and leave, we've dotted the I's and crossed the T's on a lot of issues that we address on every fire. And we do that. We start off every morning with the RFS, and we have a briefing which covers all the weather behavior patterns, any risk of thunderstorms. We talk about current fire, the current fires that are out there, the fire behavior that each one presents us. We go over all the CTAF frequencies, so we start a communication plan right on the ground. And again, we go over any applicable NOTAMs that may affect us as aerial firefighting aircraft. So for us to be informed and stay informed, we started off with that, and then every other tool that's available to generate general aviation aircraft is we use. We go through NAPES. We go through the weather and flight planning process with NAPES. There are other apps that are capable of providing us the same information. But NAPES is the one that we prefer. NOTAMs, we check our NOTAMs. We use a BOM forecast. They're great for watching the thunderstorms. We all have our individual thunderstorm apps to supplement the information that we brief on every morning. So all this is for us to understand the conditions that we're going to be dispatched in and have a pretty good idea of what we can expect from the time we leave the airport to the time we get to the fire, and of course back to our reload bases. So that's the general overview, and I hope it put some insight. And I think I'll put it back to Shaun for some questions and answers, and we'll do our best to try and respond.
Thank you very much, Rick. We've had such a great time presenting that we may have to skip over some. I've got 3 questions I can see there in the chat. I think we will need to move on just with the time we have available, but I believe we will be able to answer all of those questions there in the chat in our post-webinar email. Looking at the questions, I do hope that Rick has been able to answer those for the attendees. So just a couple of points to wrap up. Thank you so much for being here again. You've all certainly done very well to be here. We are taking submissions through Flight Safety Australia for close call accounts and events. If you've ever had a close call around any of those items there that you'd be happy to share with us, please have a think about sharing it with Flight Safety Australia. There is a link there that you can go and pop that information in. And I believe if your story is picked and published, you will get a little bit of kickback from us, which is always nice and fantastic. And just to wrap things up, again, I would love to thank Rick for being here with us today. It is an absolute pleasure and a bit of a treat to have someone of your experience here to give us that insight and information. So thank you very much, Rick. Just a note for the next webinar at this stage, it is planned for February next year, so keep an eye out through the normal communication channels and we will announce some further information early next year. So once again, thank you very much. I hope you've had a good time and have a little something to take away for your afternoon. Enjoy.